Hello friends and welcome back to our official AXS YouTube channel, and in today's lecture we are going to see one hot topic. Not that hot topic. The hot topic is about the sun, because the sun is the very hot object in our solar system, and it is also a very closest star to us to study about the star. Yes, you see a lot of stars in universe or cosmos, but the sun is our host star and it is very close to us, around the 15 crore kilometer from the earth, and we need to study about the sun in detail because sun affect not only the earth's environment, it affect on all the solar system space environment. So it is very important to study the sun effects or the sun details. And one of the feature of the sun is that sun has the black spot on its photosphere. Photosphere means it's a surface, you can say that. So what is this black spot or dark spot of the photosphere and how they created, what is the significance of the study we are doing about this black spot. No, each and every day we are study this black spot, analyze its position and all things. So this all we are going to see in this video. So let's get started. Sun, the sun, our host star. In this vast unknown universe, the only supporting giant celestial body is our sun. In cosmic view, sun is the just average size star, not much big or much small, though it is a very reason and have main role in life evolution and also life sustaining. Do you ever see sun with filtering its light? When you see or when you use a sun filter to watch sun, you can observe the small black spots on its photosphere, and if you do this for a few days, then you can observe the dance of these spots. So what exactly these black spots on sun and how they are created? Is there any impact of them on planet Earth? Let's see the answer of these questions. What are the sunspots and how they create? Sunspots are regions on the sun with magnetic fields that are significantly greater than those seen elsewhere, roughly 2500 times stronger than Earth. The magnetic pressure rises as a result of high magnetic field, while the pressure in the atmosphere outside falls. As a result, the temperature decreases in the relation to its surrounding because the concentrated magnetic field prevents hot, fresh gas from rising to the surface of the sun. When two sunspots have opposite magnetic field, they typically occur in pairs. A typical sunspot has a lighter area called the penumbra encircling a dark area called the umbra. The sun's photosphere or outermost layer is approximately 10,000 degrees Fahrenheit, whereas the umbra is approximately 6,300 degrees Fahrenheit, which explains why the sunspot appears relatively black. Give that their average size is roughly equal to that of Earth, sunspots are quite enormous. Sunspots are classified on the basis of appearance and complexity. The classification system includes simple sunspot, a small isolated sunspots with a single dark core and no penumbra; complex sunspot, large spot with multiple umbra and penumbra indicating more complex magnetic structures. Sunspot evolution. Sunspots have a finite lifespan, typically ranging from a few days to a few weeks. They form, evolve, and eventually disappear. The process of sunspot formation involves the emergence of magnetic flux from the solar interior to the surface. As the magnetic field interact with the surrounding plasma, sunspot can grow in size and complexity also. Solar cycles and sunspot numbers. The number of sunspots on the sun's surface varies over an approximately 11 years solar cycle. During the solar maximum, the sun exhibits a higher number of sunspots, while during solar minimum, sunspot activity decreases. This cyclic behavior is associated with the reversal of the sun's magnetic pole. Solar flare and coronal mass ejection. Sunspots are often the source of solar flare and coronal mass ejection. Solar flare are the bursts of energy and light while the coronal mass ejections are the massive eruption of solar material into the space. The both phenomena can have significant impact on space weather, affecting satellite operations and also communication system and power grid on Earth. Coronal mass ejection and solar flare are extremely large explosions on the photosphere. In just a few minutes, the flare hit to several million degrees Fahrenheit and release as much energy as a billion megaton of TNT. They occur near sunspot, usually at the dividing line between areas of oppositely directed magnetic field. Hot matter called plasma interact with the magnetic field, sending a burst of plasma up and away from the sun in the form of flare. Solar flare emit X-ray and magnetic field which bombard the earth as a geomagnetic storm. If sunspots are active, more solar flare will result, creating an increase in geomagnetic storm activity for Earth. Therefore, during sunspot maximum, the Earth will see an increase in the northern and southern lights and possible disruption in radio transmission and power grids. The storms can even change the polarity in satellites, which can damage the sophisticated electronics. Therefore, scientists will oftentimes pre-position satellites to a different orientation to protect them from increased solar radiation when a strong solar flare or coronal mass ejection has occurred. Influence on Earth climate. The direct impact of sunspot on Earth's climate is still an area of ongoing research. Some studies suggest a correlation between period of lower solar activity and cooler period on Earth. The exact mechanism behind this potential influence are complex and involve variation in the solar radiance and other factors. The solar cycle. The sunspot increase and decrease through an average of 11 years. Dating back to 1749, we have experienced 23 full solar cycle where the number of sunspots have gone from minimum to maximum and back to next minimum through approximately 11 year cycle. We are now well into the 24th cycle. A fascinating feature of solar cycle is that from roughly 1645 to 1715, the sun experienced almost little sunspot activity. The Maunder minimum is the name given to this sunspot minimum era. A portion of Earth experienced the little ice age during the Maunder minimum. In what manner does Earth's climate depends on solar output? The scientific community disagree on the extent to which solar activity influences Earth's temperature. Studies have indicated that variation in the sun's energy production over a tens or even hundreds of years can have an impact on the Earth's climate. There is practically no correlation between period of maximum sunspot activity and an increase in solar energy output. So in conclusion, sunspots are dynamic feature on the sun's surface driven by magnetic activity. Their study is crucial for understanding solar dynamics, predicting space weather, and exploring potential connection to Earth's climate. Ongoing research and advancement in observational techniques continue to enhance our understanding of this intriguing phenomena. So guys, this is for the solar spot and impact of solar spot on Earth. So keep yourself updated by joining our podcast. Do subscribe our channel and share this podcast to other your astronomy fellow. Thank you. So guys, I hope you understand about the black spot or dark spot of the sun's photosphere, how they created, what is the significance of the study of the black spot. So guys, if you want to see the black spot of the sun, then you need a filter with your telescope or your binocular which actually eliminate or reduce the 99.9% of the sunlight, and you can see the black spot on its surface. So guys, if you want a similar kind of video on the knowledge of astronomy and space science, then why are you waiting? Do subscribe our channel, and if you like this video, then hit the like button on the below side and share this video. So thank you for watching this.